Hello, everyone, and thank you for joining us today. My name is Manal Bahabashi, and I'm the Associate Vice President of Research Partnerships at the Natural Sciences and Engineering Research Council of Canada, also known as NSERC. I'm pleased to host this armchair discussion between the President of NSERC, Professor Alejandro Adem, and the chair of the expert panel assembled by the Council of Canadian Academies, Dr. Shirley Tillman. Je veux d'abord rendre hommage au peuple autochtone de toutes les terres sur lesquelles nous nous trouvons.
Firstly, I want to begin by acknowledging the Indigenous peoples of all the lands on which we find ourselves today. We are meeting on a virtual platform, but I want to take a moment to acknowledge the importance of the land on which we live and which we all call home.
Ancestral, unceded territory of all the Inuit, Métis, and First Nations peoples that call this land home. To help set the stage for this discussion, let me provide some background. As part of its NSERC 2030 strategic planning exercise, NSERC turned to the Council of Canadian Academies to convene an international expert panel to review what is known about how successful funding practices for supporting natural sciences and engineering happen around the world. The panel also explored how some of these funding practices could be applied here in Canada. Ce matin, le Conseil des Académies canadiennes a rendu public le rapport dans lequel il...
This morning, the Council of Canadian Academies released the report in which it presents its findings. You may not have had a chance to read the full report, but today's discussion will highlight some international practices in the funding of research in the natural sciences and engineering.
Tillman, the chair of this exceptional international expert panel, here with us today to discuss the report and her experience on the panel. Dr. Tillman became Princeton University's 19th president in 2001, serving on the Princeton faculty for 15 years before being named president. She came to Princeton as a Howard A. Pryor Professor of the Life Sciences. 2 years later, she joined the Howard Hughes Medical Institute as an investigator. Dr. Tillman was the founding director of Princeton's multidisciplinary Lewis Siegler Institute for Integrative Genomics, and she was also one of the founding members of the National Advisory Council of the Human Genome Project Initiative for the National Institutes of Health. She is renowned not only for her pioneering research, but also for her national leadership on behalf of women in science, and for promoting efforts to make the early careers of young scientists as meaningful and as productive as possible. Dr. Tillman has received numerous awards, including Princeton's President's Award for Distinguished Teaching and the Lifetime Achievement Award from the Society of Developmental Biology. Dr. Tillman serves as a trustee for several organizations. This includes the Institute for Advanced Study, Amherst College, the Broad Institute of MIT and Harvard, the Simons Foundation, and the American Academy of Arts and Sciences. Dr. Tillman is also a fellow of the Harvard Corporation. Welcome once again, Dr. Tillman. And Professor Adem, I will now turn the floor over to you to get the discussion started.
Thank you, Manal. It's a real pleasure to be here with you today, Dr. Tillman. And before we dive into the report, I want to thank you and all the committee members for the time and dedication spent on this report. It is really very much appreciated, not only by NSERC, but by the whole community. So let's get started then, if you will. And well, the first question, can you tell us what of the findings you found most surprising in this report?
Well, thank you, Professor Adem, for the opportunity to tell you about our report. There were a number of surprises, I will say. The first was really the degree to which there were common issues that were being encountered by funders all around the world, in Asia, in Europe, in South America, in Australia and New Zealand. Some of these issues have to do with the way in which science is evolving at the moment, and some of it had to do with just the scale of the efforts that were challenging these organizations to manage. The second surprise is how often they were willing to experiment, to try new things. And the third surprise was how often those experiments were not being rigorously evaluated. And that made the job of our committee more challenging in the sense that we could talk about the design of experiments, but rarely were we able to say whether they had succeeded or failed.
That's quite remarkable. As science funding agencies, indeed, they have to adopt scientific methods and procedures. So I find that very interesting. Now, could you tell us in particular about the promising and successful research practices that your panel found, in particular those related to natural sciences and engineering? I'm sure that the public would like to hear about those.
Well, before I answer that question, I just have to add the proviso that for very few of them did we have rigorous evidence that they were successful. So most of them, I think, fall into the category of promising. So the first one I would mention, and probably the one that had been evaluated most rigorously, were practices in both the European Union as well as in Netherlands as an individual country in designing what they called segmented awards. And these were awards that essentially evaluated scientists at 3 different stages of their careers: at the beginning, mid-career, and then more senior investigators. Not only were these evaluated separately, but what was even more remarkable, at least to our committee, was setting aside very specific pots of money for each of those career stages. In addition to ensuring that the very best science was being funded, we felt that one of the great advantages of these kinds of segmented awards is they ensured that a funding agency was encouraging sort of a broad demographic move from one career stage to the other. And we could see lots of benefits to funding agencies for that. The other sort of very common issue among funders was how to best fund high risk, high reward science. Everyone wants to do it. Everyone wants to find the very best individuals who are willing to take risks in order to break new ground. 2 things we found were important to agencies as they look for ways to succeed in this. One was flexibility, and flexibility to the scientists so that they could change direction as they obtained results. The other was to fund those individuals for slightly longer periods of time. Often what we were hearing, for example, grants that lasted at least 5 and sometimes 7 years. And I can just tell you as a personal anecdote that when I became a Howard Hughes investigator, as Manal mentioned in the introduction, which gave me 7 years of funding, I completely changed what I was working on and ended up doing the very best work of my whole career because I had a longer period of time to try out new ideas. So I'm very much in favor of at least some fraction of the grants that are intended to support high risk, high reward science being of longer duration.
Those are very interesting lessons. I agree, having sustained funding so folks can really give it their best and dare to reach the heights that they have the potential to do is really, I think, a very interesting and important concept. And the segmenting, again, the career progression, that's an issue we hear a lot about, and the arc of people's careers, with different priorities, different demographics, and making sure that it's healthy at all the different stages. So those really resonate a lot with our community. Now, I want to ask you, as you know, you are an excellent role model for women in science, and you're also known for your efforts to help early career researchers achieve their goals. Now, in this international environmental scan which you did, which methods or procedures show promise for further supporting underrepresented groups? And as you know, this is a big issue in Canada that we want to grapple and tackle.
I would have to say that the most successful program that we saw that was directed towards expanding opportunities for underrepresented groups in STEM was the Athena Swan Charter in the UK. This was an effort that was set up to essentially assist institutions in expanding opportunities for women, although I think the principles that Athena Swan set up could be adapted for underrepresented minorities as well, and not to mention Indigenous researchers. So it's a very successful program. Several of the funding agencies in the UK have adopted it as a requirement that institutions participate in this charter. So I think it's certainly worth NSERC having a look at it. The more specific issue or example related to funders is, I think, the importance of setting expectations for inclusiveness. I always say that funding agencies have both carrots and sticks, and using them effectively, I think, is a very important role for funders to play. So no one is in favor of quotas. But I think setting expectations that institutions are paying attention to EDI issues and that they are making progress is something that funding agencies around the world are starting to think about how to do more effectively. I think we paid particular attention in the report to how best to support Indigenous researchers and to fund Indigenous research. And what we heard over and over again from countries that have the similar kinds of questions, Australia, New Zealand, for example, Brazil, that it is important to think about that question as a unique issue for the funding agency, as opposed to just saying, well, we're going to apply exactly the same policies we use for everyone else. This has nothing about reducing a standard of excellence. It is rather thinking about what those populations in particular need in order to do their very, very best work.
Well, indeed, the working with the Indigenous communities is, of course, a high priority for the Tri-Council. So we'll be looking carefully at the report and those lessons. And I do want to mention the Dimensions program that has been launched here in Canada, inspired by Athena Swan. So hopefully we're making some progress on that front. Now, of course, we are living in the throes of a pandemic, the COVID-19 pandemic, and we see a number of things happening across the world. What impact, in your opinion, has that had on research funding?
I think it's had quite a profound impact, and I can tell you that it had quite an impact on the way in which this committee worked. We, from the very beginning to the very end of this study, we worked remotely. So we learned how to essentially conduct a study of this magnitude completely electronically, which was an experience all by itself. But more generally, what I would say is that there are some very interesting lessons, I think, that we learned during the pandemic, and changes in practices that I think will be sustained after the pandemic is behind us. First, funders learned how to get money out the door fast and in response to a crisis. That has not really ever been called upon for science agencies to have that kind of a response, but we've never had a global crisis of this magnitude. So funding agencies learned how to be nimble and how to be quick. I think the community at large learned finally, after years and years of people encouraging this, how important open science is. How important it is that we get our research findings out into the public domain. After all, it is the taxpayers who have paid for it. They deserve to have this information disseminated as quickly as possible. And I know that you are in a field that is used to actually using things like preprint servers, but I am not. And the field of biomedical research in particular really, I think, has finally learned the importance of this. The genie is out of that particular bottle, and I don't think it's going back in. On the downside, I would say we have learned about the vulnerability of women scientists with small children or even teenage children. We all know the degree to which women have been disproportionately affected by this pandemic, and it exposes, I think, for all of us, the many ways in which women are demands on women's time is different than demands on their male colleagues. And it's a reminder of why we need to be continuing to pay attention to that. And lastly, I would say the response of the scientific community to the development of vaccines is a testament to the importance of fundamental science. NSERC is renowned for its commitment to fundamental basic research. And now you have an almost perfect example of why that commitment to deep, fundamental, curiosity-driven research is so important, that it is the seed corn that will allow something like an mRNA vaccine to appear in less than a year. It was nothing short of a scientific, it wasn't a miracle because, of course, the research had been going on for 30 years, but it was a great achievement. So I think those are some of the lessons we've taken away from the pandemic.
Well, that's indeed, the disproportionate impact on women, caregivers, and members of at-risk group of the COVID-19 pandemic. We definitely see it here in Canada among our research community, and efforts are being made to address that. And moreover, it's going to be a long-term impact. It's not just going to be they're done after a few months, and have to be properly assessed, and application for proposals, etc. All that has to take into account that impact. And what you say about it, yes, go ahead.
No, I was just going to add, because you're absolutely right about that. The other group that has been really affected are our students and our postdoctoral fellows across all the fields of STEM. Their careers have been put on hold. Their ability to conduct research has been put on hold. Many colleges and universities that would normally be doing searches to fill new positions put those searches on hold. So I think we have the potential of losing almost a generation of young scientists. And so funding agencies, I think, are going to need to pay a lot of attention to the ways in which they can support those young trainees today.
Absolutely. And now, what you mentioned these sort of long-term grants. Would you like to maybe give us some more details on that? What you think would be a good model, sort of the levels, the sorts of type of grant that you think would be the best in terms of this creating a more robust environment for research?
So I think what the group would definitely say is that we found examples of funding agencies that support some relatively small fraction of their scientific community with these longer grants. I think the biggest challenge, quite honestly, in designing a program that is going to do that is to design the right peer review process. Because if you're going to make a 7-year commitment to a scientist, you had better have some conviction that would be a good long-term investment for your agencies. So some of the best practices, I think, are going to actually involve how you actually think about reviewing such proposals. What instructions do you give to your reviewers? This is an issue that I have seen play out in the United States, where the National Institutes of Health, for example, have created grants of this length, but they've had to do it with different review processes than the major grants that are normally, for 3, 4, or 5 years. So I think crafting these kinds of programs is important, but you have to be very careful.
I agree. I think program design is extremely important, and sometimes folks forget that you might have a lofty idea, a lofty goal, but if your design is not the best one, that really will get in the way. And the review, having the real experts involved in a way that is meaningful, fair, and equitable is extremely important. So that point is very well taken.
Yeah.
Now, another thing which we found that in funding agencies is that we have been asked, and we are much more active now as promoters of scientific norms and practices. So how do you see that developing? What's your opinion about that?
Well, I think it comes back to the old idea of carrots and sticks. That funding agencies probably, 30, 40 years ago thought all they had to do was evaluate proposals and send the money out the door. But I think now funding agencies across the globe are recognizing the role that they can play in setting cultural norms. And we've already talked about one of those, which is the importance of setting expectations for EDI. There are very few funding agencies around the world now who are not thinking about that question. Another sort of broad category would be sort of the importance of scientists engaging in both education and in public engagement. And I know NSERC does this very effectively, which is asking its scientists not simply to do experiments and publish your papers in scientific journals, but to realize that scientists have a role in explaining the science to the public. And as you know, Alejandro, we live in a time when science is being misunderstood, sometimes maliciously, sometimes just lack of education. And I do think agencies asking scientists to participate in public engagement is really going to be important. And then I think the last category, which I think all funding agencies are very sensitive to, is the need to establish and require that there be the ethical conduct of science. And that means, of course, educating our trainees on the ethical conduct of science. So I think these are all ways in which funding agencies are trying to not sort of get in the way of what their grantees and their educational institutions are doing, but to say these are social norms that we have expectations for.
No, I really do share emphasis on the promotion of science, and creating, really strengthening the culture of science in a country around the world. Because, if we put science on a pedestal, pedestals are knocked down. It has to be something much more solid than that. And it's very important. And when we hear discussions about vaccines and misinformation, like hesitancy, a lot of it you see is like this yin and yang view of science that the population has. So if they have a personal experience and anchoring with science, it's much more robust and will last longer, and will have also an impact on the young people, the children, and in the schools, etc. So
absolutely, yeah.
Yeah,
no question.
Another topic, of course, is the research integrity, which now is much more complex. It goes beyond just issues of plagiarism and things like that. And I know the funding agencies are again grappling with that in a number of different contexts. So,
yeah, I think the issue of conflict of interest has clearly become one of the critical issues in terms of setting norms for how scientists are intended to interact with the private sector, and very important in my view that we do interact with the private sector, but B, we do it in a way that is ethically justified.
Absolutely. Now, okay, so you did this sort of a scan of the best practices. Now, what factors should we be considering when applying these practices in natural science and engineering to the Canadian context? What are the opportunities? What are the gaps? Yourself as a Canadian and American, you lived in both places. What wisdom can you share on that?
Well, you've raised a question that the committee did spend a fair amount of time discussing. We were privileged to have a number of very distinguished Canadian scientists with us practicing in Canada. And so we were able to have, I think, quite meaningful conversations about the Canadian context. And we asked ourselves basically a number of questions. One is, are there aspects of Canada that are so unique that many of the practices that we reviewed just would not be appropriate? And the answer is probably there are very few examples where Canada is completely unique. I'll give you an example that came up in our discussions, that because Canada has a federal system, it means that there are often multiple funding agencies for that would be appropriate for scientists to apply to. This is a plus in a way because it means you have more opportunities to find funding, but it also makes navigating the system more challenging. So that was an area where I think there are countries that are very centralized where this problem doesn't exist, but there are others obviously very much like Canada. We looked at some of the key challenges and opportunities that Canada faces, and clearly one of the things that came out in our discussions was the low amount of R&D investment coming from the private sector. And I gather from conversations with my colleagues on the committee that this is a long-standing issue for Canada. And frankly, I don't see it as NSERC's issue, in the sense that as far as I could tell, NSERC does a great deal to try and actually encourage scientists at universities and research institutes to engage with the private sector. The issue seems to be more with the private sector. And whether this is a public policy question that relates back to federal or provincial policy was never really clear to me. But it does, I think, represent a challenge for Canadian science, that there isn't a greater partnership between the private sector and NSERC-funded scientists. The last thing that we would say is a challenge for the Canadian context is the absence of really impactful philanthropy. And we had on our panel individual from the UK who could talk about the impact that the Wellcome Trust, for example, has had on UK science. It's just enormous. There's no question about it. And I would say in the United States, the impact of philanthropy, whether it is, sort of very well organized philanthropy from something like the Gates Foundation or individual philanthropy from individuals, they are making a big difference. And they're often able to fund in a way that federal agencies simply are not going to be able to fund. So I think for Canada, this is a challenge. It's not that Canadians don't take advantage of these philanthropies that exist elsewhere, but philanthropies often favor their home institute, their home country, and so I think it is a challenge for them. The last thing I would say is what we heard over and over and over again in our conversations with funders from around the world is that the biggest challenge for a funding agency is how to balance competing priorities. And one of the most profound, I think, of these competing priorities is whether to provide the top, let's say, 5% of scientists with ample resources to be able to do their work and therefore potentially make groundbreaking new discoveries, or whether to spread funding more broadly so that everyone has a chance to show what they can do. And I know NSERC deals with this all the time. This is a major issue for you as you think about how to how to create your portfolio so that you're doing both, because of course you want to be able to do both.
Absolutely, those are extremely good points. And I know you've been involved with the Simons Foundation. I guess you were mentioning, what's the size of their portfolio?
So the Simons Foundation is giving out over $500 million a year, which is a stunning number, to fund fundamental science. And as you know, they primarily fund mathematics, physics, astrophysics, computer science, but they actually even have a pretty significant biology program as well in marine biology and in autism research. So, they can go in and create opportunities for scientists in a very nimble way that is often harder for a major, large federal agency to be able to do.
Absolutely. No, point well taken. All right, now, when we want to measure the success and the best practices, of course, we want evidence. So how can we improve the evidence base for funding of natural sciences and engineering?
The major thing that occurred to me as we were doing our study is here we are, we're all scientists. We all believe in evidence-based decision-making. We all believe in the power of data to tell us what to do. And yet what we were finding is the absence of applying all of the scientific method and its technologies to the way in which we fund science. So I think one of the conclusions that we reached is that this is a time to experiment. Science is moving with lightning speed at the moment across, I think, almost all branches of science are moving with lightning speed. And the way in which we function is changing. The difference between tabletop physics and particle physics, those are huge differences in the cultures and the way we need to think about how to fund our science. So I think it is a time to do some experiments. Clearly, when you do an experiment, you don't bet the farm. You do it with small programs where you can evaluate the success of the programs and then determine whether that experiment should be expanded to other parts of your portfolio. The only thing to be conscious of, however, is that science is hard to evaluate in a short-term way. Going back to what I said earlier about fundamental science, that often you do not know the consequence of some scientific discovery that is going to be felt by, the citizens who paid for it. Often the time frame is 20, 30 years. So it's not easy to figure out how you're going to develop the right metrics that would determine whether a funding experiment was a success or was a failure. And I think that's going to be a challenge as we, make the recommendation to do some experimentation. I would say the other thing I would add is that, and I've said this earlier in our conversation, but I'm going to just emphasize it again. One of the things we began to appreciate in the study is how important context is. That there are going to be ideas in this report and practices in this report that simply will not work in Canada, or that would work, sort of in a very uninteresting way in Canada. That countries have very different cultures, and what works in one doesn't always work in the other. So maybe that's a way of saying, take our report with a grain of salt.
No, I understand. No, and I think we're going to treat this as scientists, right? And I like very much you're applying the scientific method to experimenting, but you're doing it in a controlled way, and also be careful about the context in which you're doing your experiment, in which things are adopting. That's, I think, extremely important.
Yeah.
I personally also see the data as being a key ingredient, a key, in fact, resource that agencies have. We are sitting on data from proposals, data, of course, also about applicants, and how we mobilize that data and we can use, of course, technologies from AI, et cetera, to try to understand trends in funding. And so in that direction, we recently appointed our first chief data officer at INSERT, and we look forward to working with folks at Statistics Canada and others to really create a robust repository of data for whatever we want to do. And of course, measuring the impact when you explain to government, well, what happened? We gave you this money and what did you do with it? That, of course, is a challenge. And that's where we want to reach out to the community and try to develop those metrics that might make that case. But as you say, it is a huge challenge that all of us are facing. And I do want to mention here that there are these organizations that bring in funders, like the Global Research Council, where we can compare best practices and have workshops, et cetera, to try to deliberate more leisurely what these best practices might be that they emerge. Okay, well, now, finally, what I want to ask you, when you work on such a fairly large report, which, has a pretty broad scope, what were the challenges in analyzing and summarizing the information gathered for the report?
The biggest challenge was functioning in a pandemic. So that I must spend a minute commending the staff of the CCA. They were simply extraordinary. How they managed to pull off this report and to be, I think, the most instrumental among the group in collecting the kind of practices that exist around the world, and then trying to assess the degree to which those practices have been instituted and evaluated. It was just simply extraordinary. I'll give you just a sort of an example. One of the ideas and early practices that experimental practices that we heard about was to use as part of the peer reviews process what were called partial lotteries. And of course, those of us who have grown up and lived our whole careers in believing in peer review as the gold standard, all of us sort of our backs went up at the thought of a lottery to determine who gets funded. But the idea is really to do an initial sort of screen of applications and get down to perhaps the top, let's say 100 where you can only fund 30 or maybe even 25. And having sat on review panels that are facing that kind of a challenge, I can tell you, making the distinction between the 25 that will be funded and the 75 that won't you're counting the number of angels that dance on the head of a pin. The distinctions are minuscule. And so several funding agencies are doing actually these partial lotteries. You get down to 100 and then it's a lottery. And the interesting thing that we discovered is that the scientists themselves felt as though this was fair. And I think one of the keys to successful peer review is believing that it is fair. Yeah. And one of the things that happens when the success rate falls too low is that people lose faith in the peer review process. So by the time we finished discussing partial lotteries, I think we had all come around to the idea that that is an example of an interesting practice that might be a very good one to test in the future.
No, that's quite fascinating, and I certainly had that reaction that you mentioned when I first saw it, but recently in some discussions in a different context where it was explained how it was going to be applied, I can understand, and indeed, if something is just hyper-competitive and the success rate is incredibly low, it does become in some sense a lottery. once you have all the qualified people.
Yeah.
So,
and there is a sense that if it's a lottery, we all understand that lotteries, are basically fair. There's no bias built into a lottery. The other thing I would say about the lottery as an idea is it eliminates the sense of bias that creeps into peer review. And we know, there must be now 100,000 social science studies that have shown the degree to which we all suffer from implicit bias. And I think the bias in peer review is there, despite the fact that I now know that agencies are trying very hard to educate reviewers on the nature of implicit bias and to help people identify where their implicit biases are. But, they affect gender, they affect underrepresented minorities, and I think, frankly, and this will matter to a country as big as Canada, it affects the sense of whether a small regional university has a chance to be funded when stacked up against a grant that's coming from a very well-resourced and very well-known university. So lotteries might actually help solve at least some fraction of the sense that we are human and we have these biases that influence the quality of peer review.
Absolutely, very fascinating discussion. And I would suggest calling it an aleatory method or a randomized process. Maybe I reassure some of the researchers that ignore.
I agree.
We've reached pretty much the end of our time. And we really want to thank you, Shirley, for such a fruitful discussion and for sharing your insights. I also want to thank, of course, the rest of the committee members for their hard work and the Council for Canadian Academies for the magnificent job of orchestrating this whole process. So kudos to all of you. And now I'll turn it over to Manal for a wrap-up of our event. Thank you.
Thank you so much, Dr. Tillman and Professor Adem, for guiding us all through such a fascinating discussion about a very timely report. The findings will give NSERC and our community a lot to think about as we develop a long-term plan for natural sciences and engineering research in Canada. Nous vous remercions, ainsi que les membres du comité d'experts.
We thank you and the members of the expert panel for your dedication and the time that you have committed to this project.
On this report, it was a real pleasure to hear your insights. And we invite the community to take a closer look at the report. Please visit the main webpage for NSERC to find a link to the report. Thank you, everyone. Have a great day. Bye.